Excellent. Hello, everybody. Welcome back after lunch. How are you feeling? Sleepy? Uh-oh. At least it's cold in here. I'm Simon, and we're going to be talking about software architecture, obviously, and the balance with agility. Some background on me. I live here. Everyone's going, oh, what's that? It's about a 3-pixel wide island called Jersey. It's near France. Why? Basically, I was born there, went to school there, ended up going to the UK, went to university, worked in London for about 12 years, mostly for consulting companies, predominantly doing Java stuff. I have some small boys, 9 and 6, and we moved back to Jersey about 5 years ago. Lovely place for children to grow up. Not much Java. So I kind of faced a choice. Do I give up, teach people how to surf? But at the time I couldn't surf. I can now, debatable. Or do I switch technologies? So I jumped onto the .NET stack. It's complicated, right? The next question is usually, is Jersey part of the UK? Do you use the same money? Do you have your own laws? It's kind of complicated. I'll just refer you to this awesome YouTube video. What do I do now? I guess for the past couple of years, I've been helping software teams understand software architecture. And that kind of sounds crazy, but in my experience, a lot of software teams don't get architecture. So I've been helping them do this, and I've been helping them understand how to do architecture in agile environments. And again, these things seem to conflict. I've traveled all around Europe over the past 2 years. I've spoken in China and I've spoken in the US, and I see the same patterns repeated over and over again. I do code as well. So granted, I've not coded as much as I'd like this year, but I'm a software developer by trade. That's what I do. Why do I want to talk about software architecture? For me, it needs to be made much, much, much more accessible. So when I worked here in London, one of the things that we needed to do as a consulting company was to scale the number of teams we had. And in order to scale the number of teams, we needed to scale the number of technical leaders, in other words, the number of architects. So essentially, internally, in-house, we did some architecture training. And that is, in essence, what all of this stuff has become. I started writing a book about 18 months ago. It's an ebook on leanpub.com. As a thank you from me to you, I'll flash you up a code at the end, which you can use for a discount. What am I going to talk about? I'm going to brush across a lot of the topics we've seen already in the conference. So Rob Smallshire talked about architecture in a kind of agile world. We'll touch upon some of that. Tom Gilbert in his keynote this morning talked about architecture as an engineering discipline. I think he's completely right, by the way. I think we should be striving to make software much more of an engineering discipline. I don't think we're ready yet. I think he's potentially 20 years too far in the future. We've got some work to do right here, right now. But the principles are absolutely sound. And I'm going to talk about drawing pictures. Charming. I'm going to talk about drawing pictures. So if anyone went to Owen Wood's talk this morning about UML, I'm going to talk less about UML and more about communication through pictures, through sketches. Oh, God, I've got to start with this, haven't I? What is architecture? Tom said there were like 200 different definitions out there on the SEI website. Mine's really very simple. Architecture is about structure, so the boxes and lines, the things, the components, the modules, the subsystems, and how they link, how you decompose something. But it's also about vision. Given this blank sheet of paper and some requirements, how do we create that architecture, and why are we making these decisions? So one of the things that Tom said is essentially requirements drive architecture. Without requirements, there is no architecture. There's no purpose here. So yeah, definitely agree with him there. What's software architecture more specifically? There are a couple of terms kind of banded around. Application architecture is one that most developers are familiar with. Take a code base. It's about structure, layers, components, APIs, programming languages. It's quite code-focused. Systems architecture is kind of a bit more high level. Again, there's a very traditional definition of systems architecture, and it's around software systems, components, modules, and hardware. This is way, way different, enterprise architecture, not what we're talking about at all. So we could talk for the next 84 minutes about software architecture, but let's not do that. For me, this is software architecture. It's everything from lines of code, organization of code, structure of code, up to making sure a software system works end to end. Integration points, the whole lot. It includes infrastructure and hardware. And it has to, right? Again, Tom talked about constraints being one of the big driving factors behind an architecture. Target deployment environments, hardware, infrastructure. Again, a key constraint here. Now, I'm not saying that we should all go out and be able to create networks and provision infrastructure, although that would be cool, you know, the whole DevOps movement, but we should understand infrastructure. We often use the word design a lot. You know, when I'm designing something from scratch, when I'm doing architecture, what's the difference? Grady Booch had this nailed a long time ago, in my view. So Grady Booch basically says, architecture is about the significant stuff, significant decisions, things that are expensive or costly to change. Choice of language, choice of technology, choice of platform, choice of the overall architecture, client-server, rich app on your mobile rather than a phone gap type app, for example. You know, these are the major significant decisions that you kind of need to get right because they're expensive to alter later. We've got some great refactoring tools now. ReSharper, IntelliJ, Eclipse. You can refactor a lot of stuff very, very quickly, but you can't refactor some of those significant decisions. What's the whole point of architecture, right? For me, it's to avoid chaos. A number of teams that I see are basically in chaos. Okay? If you ask them these two basic questions, do you know what you're building? If they can't answer you, if they can't say, here's a list of features, or give you a quick 5-minute elevator pitch on what the system is supposed to be delivering, then yeah, maybe there's something wrong here. I've worked with teams, and they've often not known how they're building it. So one of the systems that I kind of took over a while back, it was a .NET system, end-tier architecture. If you asked a developer on the team how they would build a web page through to the back-end services, you'd get different answers depending on who you spoke to. So people had different views of the layering strategies, for example. Again, that seems to strike, you know, that's chaos. And we need to stop all this because if we don't think about architecture, if we don't think about significant decisions, we get a mess, essentially. You know, big balls of mud style of architectures with no defined structure. Who's working on these? You're all liars. You're all working on these things, right? Or you get systems that don't work. You know, they are too slow, they don't scale properly, they have security issues, they're hard to deploy, they fall over, that kind of thing. And again, architecture allows us to think about some of these characteristics. How have we as an industry traditionally tried to prevent chaos? Well, what you do is you go find an architect. You hire an architect. You point them at a problem, and they come up with a solution. And sometimes they document that solution. Nice, thick, sad. How does that make you guys feel? Yeah. Yeah. Sometimes when you pass out on the table. So what happens when you give a big set of documentation to a separate development team and say, go build this, I've thought of everything for you? Does it get read? No, sometimes not. Sometimes you might get halfway through and then your head hits the table as you fall asleep. But generally, you know, we don't like getting that sort of guidance. What's the point of this? The point of this is that that document is there to create a shared understanding, you know, a shared vision that the team can work from. But the actual vision that's being created there is this. To use an internet acronym, too long, didn't read. Right, which kind of brings us back to chaos because we're not working in a consistent way. Do we do this anymore? Nah. Why? Because if you go to the Agile Manifesto webpage, what's item number 1? Item number 1 says, don't write anything down. It doesn't really, but that's the kind of lazy modern interpretation of the Agile Manifesto to some degree. So what do we do now? You know, how do we create a shared vision amongst a team of people? Who here uses UML? Show of hands. Is that 20% maybe? Maybe slightly more. What's everybody else doing? boxes and lines. Yeah, lots of people just do boxes and lines. So there are some teams who just jump into doing coding. And there are some teams who actually go, hang on a second, let's think about this. Let's go over to our whiteboards and let's sketch some ideas out. And this is the thing we're going to build. Sometimes that's not very effective. And so we get a different type of vision created. You'll have to look this one up yourselves, but sometimes we get this. And again, if there's no consistent vision here, no consistent understanding, we're basically back to chaos, which means stuff's not going to work. So for me, the whole essence of software architecture is to reintroduce structure and vision back into software teams in the way that they work. So we can build stuff that looks nice. We can build stuff that's well-defined. We can build stuff that actually works. And we're all building stuff in the same way. Now, the problem is, who's a software developer here? That's like most of us. Cool. The thing is with software developers is we kind of like code. I include myself in this as well. And as software developers, our day job is basically code, writing code. Classes, functions, methods, unit tests, refactoring, TDD, BDD, all of this cool low-level stuff. And as developers, that's exactly where our focus needs to be, right? That's our craft. But the architecture thing is all about shifting back away from the IDEs, away from the code, to look at the other stuff that drives the architecture, that influences and shapes the design and the architecture you come up with. Why? If we take some requirements and we want to produce a design, there's a ton of different options. And ideally what we want to do is we want to narrow these things down as quickly as possible. We want to come up with a single best solution. And things drive this process. This is exactly what Tom Gilb said this morning. You know, requirements drive architecture, both functional, and I'm going to use his word he hates, non-functional. Quality attributes, service level agreements, characteristics, those types of things. You know, particularly non-functionals, these are technical things. Scaling, performance, security. These things tend to need to be baked in early to the foundations. If you've ever tried to make a system go hugely faster, if you've ever tried to enhance the scalability of an existing architecture, if you've ever tried to retrofit security into an existing code base, you'll know it's an absolute nightmare. Even things like internationalization. So we build a website, and all the text was in English. And then we go, oh, do you know what? We need French. Oh, I wish you'd told me that before, because now we have to take all the text out, and it's a real pain. It just takes a long time. So again, there's some stuff that we can bake in early and save time with. Tom Gilb also talked about constraints. You know, time, budget, available people, target deployment platform, et cetera, et cetera, et cetera. Again, this stuff shapes architectures. And then there's kind of fourth category of stuff. There's principles. You know, when you're working on your teams and you choose your layering strategies and you say, well, we're going to build nicely stateless components. We're going to use a dependency injection framework. We're going to use TDD. We're going to use these coding conventions. We're going to put all of our business logic in the database to store procedures, or vice versa. Right? These are principles, and ideally the whole team needs to understand, appreciate, and follow these things. Why? So we get consistency. So what you do is you chuck all this stuff in a big bucket, stir it with a big stick, and hopefully it reduces the number of options. So that's the whole design process in a nutshell. There's obviously a bit of complexity here, right? You know, the whole process of decomposing stuff, it's a minor detail. We'll talk about that later. The thing with the architecture role, and particularly for people moving into the architecture role early in their careers, is that it's kind of hard to step away from the keyboard. Anybody experience this? Yeah, me too. You know, when you're given that first architecture role, and you're used to coding all the time, and somebody tells you to stop, step back, and look at this stuff, it's like, I might forget how to code. No, you won't. Right? That's absolutely natural. So it can feel uncomfortable letting go of the keyboard. But you know what? I've got a message for you to take away. You don't need to step away from the keyboard. Why? Because you have to write emails. You come out of meetings and you write emails. So we can still use keyboards and computers. This is all good. We don't have to turn into hand-waving, box-drawing consultants. Unfortunately, people do think this is exactly what the architecture role is about. You know, they think it's a post-technical career. In other words, once you get into that role, you're no longer technical. You will forget how to code. You can't code anymore. In ThoughtWorks, if you go Google this term, in ThoughtWorks, if somebody is referred to as being post-technical, it's like a real insult. Like, that's it, end of their career. Now it's just management forever and ever. I'm exaggerating. But for me, the essence of the architecture role is about steering the ship. Imagine we all head down to the south coast, we go to Southampton or Portsmouth, we all jump on a big boat, and we steer it to Jersey. And then we all go and sit, code away. What's going to happen? Is the boat actually going to reach Jersey? I don't know. Shipping lane's kind of scary. Waves, wind, we're going to be pushed off course. So somebody needs to be up there steering the wheel all the time. That doesn't mean that they can't code as well. Airplanes apparently fly themselves, so pilots must do something else rather than just steer. But somebody needs to at least make sure we're going in the right direction. And this is what the architecture role for me is about. Okay, so that's fluffy, isn't it? I've said, step away from the code, look at fluffy high-level stuff. Yeah, all the low-level details, the technical stuff, really, really important. Do you know why? Because you have to make sure stuff works. If you guys are given a task to go build a highly scalable system in .NET, you need to know how to do that. You need to know how to take advantage of the .NET framework, IIS, configure it, deploy it, scale things out. You need to know how to do that. What I will say is don't code all the time. Because if you're coding all the time as an architect, nobody's steering the ship. And it's kind of bad. It all comes down to trade-offs. Whenever we're taking our blank sheet of paper and we're making technology decisions, we need to know what the trade-offs are. I run a 2-day training course, and we set people a small problem, which I'll talk about later. And people work in groups. And sometimes in the early stages of this exercise, people say, well, we could build this thing in, and I'm going to pick on SharePoint. We could build it in SharePoint. And then someone else in the group will say, well, do you actually know SharePoint? And the first guy will go, no, I'm sure it's possible, though. Right, do you see the problem here? Tom Guild talked about being slightly conservative. Yeah, maybe. At least choose stuff you're familiar with. Or if you're not familiar with it, and that's fine, make sure you make a note of it and revisit that decision later with proof of concepts, pilots, whatever. And essentially, all technology decisions involve trade-offs. There's never, ever a single silver bullet, best solution ever. It's all pros and cons, and as an architect, that's the thing you need to know about. Do you think architects should code? So there's a lot of nodding and some going no very vigorously. So why not? Let's put you on the spot here.
Partly, in a sense, leaving it to those who are best able to do it.
Right, so leaving it to those best able to do it.
Partly because if you are coding, what are you doing that you've got a team of people to do for you?
Right.
What you're doing, as you say, is steering, providing guidance. If you're there as an expert coder and you're providing expertise in the code, that's a different role. That's an architecture.
Right.
Technical expertise.
Yeah. So essentially, you need to be steering the ship and looking after the architecture stuff. And if you're coding, who's doing the architecture stuff? So somebody who said architects should code, why? Yep.
Because you need to stay close enough to the code to, you need to know what your team is doing right, so you need to stay close enough to understand what's going on. But that's your design is working, you need to know what your product says.
Right, so you need to make sure, you need to know that your design's working, you need to be feeling the pain, and you need to be close to what's going on.
So that when you're steering the ship, you know what you're doing.
Right. So you can see you're getting some feedback. This isn't a simple yes-no answer. It depends. It's one of those really annoying consulting type answers. It depends. My answer is I think architects should code ideally, but there's a number of factors which will prevent this. If you think about architecture as being about the big picture, if you have a really, really, really big project, that big picture is so much more huger. So therefore, you're just not going to get time to code. You're going to be steering the ship all the time. If it's a small kind of Scrum type team, 7 people, yeah, why not? you might have some opportunities to do some coding. So there are pros and cons of doing this. The thing I will say, and again, Tom Gill picked up on this, is that software architects, it's all about being a master builder. If you trace this word back, it means master builder. And that's the metaphor we should take into this role. So in other words, the people leading the projects from a technical point of view, they must know what they're doing. They must understand the technologies that they're dealing with. They must understand how to build a scalable solution if that's what they're being tasked to build. How to build a secure solution if that's what they're being tasked to build. So we need technical knowledge here. And coding is a great way to keep the skills up to date. That's the one big issue we have in the software world. Everything just moves so quickly. How many JavaScript frameworks were released this week whilst we were here in the conference? For like 10 or something. Next year, 3 of them will be center stage. You should use this one today. Coding also kind of gets you in there with the team, and it removes a lot of the kind of ivory tower bubble type problems of me handing you stuff to do, and you go, that guy's a freak. He has no idea what he's on about. So again, I can feel the pain here. Oh, this is a strong word, control. Do you think we're trying to control people and what they do? Again, Tom Gill actually used this word, which surprised me, given he lives in Norway. There's an interesting cultural thing about this word. What we're trying to do is we're trying to prevent chaos. How do we do that? We introduce control. Is that the same as controlling what people do? I'm not sure. I don't think so. I think this is possibly too strong a word. I think what we're looking for here is boundaries, guidelines, principles, discipline, those types of things. You go to conferences like this, you see a whole bunch of talks, you leave with some amazing ideas. Your colleagues go to different conferences, they see amazing stuff, they also leave with ideas. You all get back to your project, and you all start doing stuff in slightly different ways. That's going to lead to chaos. So all of these good ideas you pick up, all of these best practices and principles you pick up, we can avoid chaos just by making sure everybody gets them. Just externalize them. Stick them on the wall, stick them on your wiki, doesn't really matter. But just agree on stuff. Imagine we're building an n-tier architecture. Agree on the layering strategy we're going to have. And let's do that early so we avoid massive amounts of rework and refactoring. Really annoys me, people use the term refactoring to mean re-engineering. Anybody else see it? Yeah, you've seen this as well. And put some boundaries in place. What you probably don't want to happen is people just randomly downloading jar files or DLLs or technologies off the net and plug it into your system. It's probably bad because you've probably got policies, you've probably got existing skills, you might have incompatibilities. And again, unless you can see the whole system, you're not sure what the impact is sometimes. It's a kind of feedback loop. So imagine you're the architect and you have a bunch of developers. You need to introduce that control through guidelines, discipline, boundaries, rigor, that kind of thing. And you need to listen to the feedback. If people are fighting you all the time, and sometimes they do because they have opinions that matter, then maybe you need to relax a little, get their input, get their feedback, and take it into account. If people are asking you lots of, I don't understand why questions, then maybe you're not being explicit about the rationale for some of the decisions you're making. And again, this can do a lot to enhance motivation and make sure people are on the same page when they're moving forward and building stuff. But this often leads to the whole ivory tower thing. I'm the architect, you're the developers, I'm going to tell you exactly what to do. At some point in time, you'll just ignore me, and you'll think I'm an ass. And then what happens? Well, nobody's looking after the big picture, nobody's steering the ship. So ultimately, it's about reducing this little gap down, ideally shrinking it entirely. How do we do this? Yeah, getting people who are involved, getting architects who actually want to be part of the team engaged constantly, steering the ship and checking what the team are doing, helping them. If you're one of the developers, this is basically making you much more, I use the term architecturally aware. In other words, it's increasing your architectural knowledge, particularly if the people making the decisions are telling you why they're making those decisions, Why are we using this specific pattern? Why are we using this specific technology? If we do this well, we can shrink the gap. So we can remove a number of the kind of ivory tower problems just by being engaged with the team. So none of this floaty, high-level enterprise architecture group stuff swooping down, dictating and beating people. You know, let's get architects on the team all the time. And if you do this super well, everybody eventually becomes an architect. That's kind of cool. What stops this happening in the real world, though? It's one word, 3 letters, begins with E, ends in go. Yeah, ego. You know, some of these people, they get paid lots and lots of cash. They've worked hard to get there. Why should they share the glory? So that's the sort of architect you do not want running your projects. So that's architecture and the role of an architect in a nutshell. Any questions before we move on? No? We're all happy so far? Excellent. So let's go agility, and then we'll tie all this back up at the end somehow. What's agility about? Well, agile is about, moving fast, embracing change in requirements, in environment, releasing often. That's how we get feedback, and so on and so forth. Like architect has like 200 definitions, agile probably has another 200 definitions. It means different things to different people. I was at the Agile 2013 conference in Nashville during the summer. Has anybody ever been to the Agile Alliance conferences? You guys got to go. You have to experience the Agile Alliance conferences. Why? They are properly fluffy. So the conference is basically software development in Agile or with Agile approaches. I swear you could send anybody on the planet, any single discipline, and they could go through that conference and think that was amazing. That applies to exactly what I do. Don't get me wrong, it's an awesome conference, there's some awesome speakers, but it's all about high-performing teams, leadership, giving each other a hug, giving ourselves good feedback. It's all of that kind of fluffy stuff that sits on top of the engineering disciplines. And that's fine, but I find most teams don't have the engineering disciplines to back this up. And that's the thing we really, 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 really need to be addressing. So for some people, Agile means fluffy stuff. I'm going to jump off my soapbox now. What's Agile software architecture? What happens if we stick this word in front of software architecture? Does that even make sense? Yeah, I think it does. It's not this, though, right? One of the things that Agile's done is it's increased the stock price of 3M, right? Because everybody's using sticky notes now. When I do my architecture training courses and teach people how to draw pictures, I sometimes use sticky notes, but this is not Agile architecture. Just because we can move sticky notes around does not mean we can change our architecture quickly. Right, this is different. It's worth noting that even if you're delivering software in an Agile way, you're doing 4 releases a day. You're doing a time box of a week, release, 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 release. Right? It doesn't guarantee you're going to get an Agile architecture, does it? Why? Actually, the opposite normally happens in my experience. Agile teams don't necessarily create Agile architectures. Why? Because they're feature-driven. If there's a pressure to get stuff delivered and get stuff out the door, it's all about stories, features, tasks, deliver, stories, features, tasks, deliver. And sometimes people forget about the architecture point of view. So then you get these kind of, we'll call them refactoring sprints, shall we? Where people have to churn massive amounts of their architecture to fit new features in. Now, okay, this doesn't happen everywhere, but I would take the whole emergent evolutionary architecture thing with a pinch of salt, because it requires very, very, very good, senior, dedicated, experienced people. So for me, an Agile software architecture is one that, well, easily reacts to change within its environment. We said that Agile was about embracing change. So an Agile software architecture is an architecture that also embraces change easily. But not every architecture is created equally. Most people build fairly monolithic styles of systems. You know, we're going to shove everything in a single client, a single web server, and we'll deploy the whole lot in one go. Is this style of architecture agile? It might be. So just because we're building something monolithic, it doesn't necessarily mean that it's not agile. If it looks like a big ball of mud inside, yes, that's not agile. The big ball of mud architecture, essentially, you try and pull one thing out, one component, and the whole system follows it. Like, you just cannot detach and detangle the mess. Everything's interwoven across all the layers and packages and classes and services and components. So that's a style of architecture. It's not a particularly good style of architecture, but it's a style of architecture. A fairly common one. If anyone went to Fred George's talk in this room yesterday about microservice architectures, you know, what about that? Does that give you agility? Hell yeah. Right? Because you're deploying these things, they're tiny, they're quick to build, they're quick to change, they're quick to replace. And we can scale them out. You know, we can have 15 of these things running in parallel, just sucking up the load. We can reconfigure our system relatively quickly. So this gives us some flexibility. You know, if we want to change this thing, we only need to change this thing, provided the interface doesn't change. So in essence, a good architecture enables agility. Now, am I telling you to go and write microservice architectures? No, because that'd be foolish of me to do that. I think Fred's talk was excellent. My concern about that kind of talk is that people go away saying, this is what we must do. And that style of architecture is not suitable for everybody, because nothing's free. It takes a lot of effort and discipline to actually build that style of architecture, because basically it's a bunch of collaborating things with well-defined interfaces. You need a lot of discipline to make that work. I love talking about extremes, and we do that a lot in the IT industry, don't we? It's either one thing or the complete polar opposite. It's never anything in the middle. Big monoliths versus microservice architectures. There's something in the middle, right? And that something in the middle is kind of, you know, a monolithic deployment unit with smaller stuff inside it. If anyone's heard the term component-based development, right, that's essentially what this is all about. So we break our system up into small, nicely, neatly, little, loosely coupled things. And then we can pull them out, sort them out. There are trade-offs. This tends to be quick to build, quick to deploy, nasty to change. This thing, more effort, more discipline, more engineering required to kind of make this work. But you get a hell of a lot of flexibility here. This thing in the middle, fairly quick to build, easy to deploy, but there are some trade-offs. You know, all of these things are built in the same language. The coupling's a bit tighter than it ought to be. So what? You know, we look at the environment we work in, we look at the different patterns and styles of architecture, and we make a choice. And we understand the trade-offs. We understand the trade-offs as doing this versus this or this. And that's what this is all about. So I'm going to backtrack for a second. What does agility mean? We said Agile was about embracing change and moving fast and fluffy stuff, particularly fluffy stuff these days. What does agility mean? Has anybody here heard of John Boyd? John Boyd? A couple of vague nods. Cool. So John Boyd was a fighter pilot in the US Air Force. And he came up with this concept he calls the OODA loop. And the OODA loop basically stands for observe, orient, decide, and act. So let's imagine we're all fighter pilots. We're having a big dogfight in the air. We're flying around really fast. In order for me to take you guys down, I need to execute this loop really, really quickly. So I need to look at the situation. I need to orient myself, so do some analysis very quickly. I need to decide what I'm going to do next, and then I need to do it. And this loop needs to take less than a second. What happens if this loop takes too long? You get killed. Right, so basically, in a one-on-one situation, both pilots are doing this OODA loop. And what John Boyd basically says is, if you can execute your loop faster than your opponents, you can get inside their loop. So while they're still orienting themselves, you've changed the situation. And you've confused them. And that gives you the upper hand. So this is a strategy that he basically created and then taught people. And a lot of the kind of US military runs off this type of concept. Great, so who regularly does dogfighting on a Saturday? Yeah. Me neither, it's kind of dangerous. So what has this got to do with anything? There's a guy called Steve Adolph at the University of British Columbia, and he really liked this OODA concept. And he said, how can we apply this to software? How can we apply it to building software? And he essentially says this. He says that agility is relative and time-based. And it's a really, really fascinating paper. You can get the PDF online. It is behind a paywall, but people have hosted it. Not that I condone that, of course. And basically what he says is, if you're in a really large, slow-moving environment, if your business changes slowly and you can keep up with it, then you're agile. If you're a startup company, a lean startup company, and you need to do releases every 2 days and you can't keep up, then you're not agile. So it's relative. That's a nice concept, isn't it? So this is often why people working in really large organizations can say, yeah, we're agile. And it's because they're moving quicker than the environment that they work in. Okay. So where are we going with this? Well, this whole OODA loop, if you break it down, is basically this. It's inspect and adapt. So you look at the situation and then you change something. And this inspect and adapt stuff, I heard this a lot in the Agile conference in Nashville. I mean, like every single speaker talked about inspect and adapt. It's essentially, the retrospective thing. We'll look at what's happened and we'll do stuff depending on what the outcome is. So how do we inspect and adapt a software architecture? Well, that's a kind of interesting question, actually. Let's take this one by one. How do we inspect an architecture? Any thoughts from you guys? If I asked you to go and inspect your systems, what would you do? Sorry, instrument it? Yeah? Sounds reasonable. I'll go with that. What would anybody else do? Read the documentation, yeah, assuming we've got some. Sorry? Yeah, checklists, do some reviews maybe. So basically, we essentially, yeah.
Say either read the code.
Yeah, read the code.
Or use some tools to read the code and abstract information.
Right, yeah. So essentially, we want to kind of look inside the code. We want to do some archaeology, dig up some of the foundations and see what's really sitting there behind the covers. Has anybody tried any of those tools? Structure 101, Endopend, LaTeX, etc. Do you like them? Some nods and some definite shaking. Yeah, I'm in two minds with them, and I'll tell you why later. Diagrams. Right, diagrams are a great way to communicate stuff. So what we can do is we can understand the existing architecture, and then we could draw some pictures. Draw some pictures to show other people what this thing's about. Issue with this? People can't draw pictures. We seem to have found an issue with the industry. People can't communicate through pictures anymore. Apart from the 20% who use UML. All the rest of us are screwed. I was in Oslo earlier this week, and I ran my 2-day architecture course, and as part of that course, we set people a small case study. And we say, design a solution and draw some pictures to communicate it to other people. Here are some example pictures. There were 3 groups in this case, and each group produced 1 picture to describe an entire software solution. Does that make sense? One really, really simple picture to describe an entire software solution? No. For those who went to Owen's talk this morning, Owen talks about having a collection of diagrams at different levels of detail and abstraction. But this is what most people do. So the sketching workshop that I'm running tomorrow, we're going to do exactly the same thing. And I've run this all over the place. And it's the same thing I see over and over again. People just find it really hard to communicate architectures. So I already asked this, and it's about 20% of you. I've asked this question in the US, all around Europe, Scandinavia, South, West, East, and China. Now, don't take this as read. I'm not an academic. I do need to do some proper research on this, but given my anecdotal evidence by the people who attend my workshops, conferences, and so on, 9 out of 10 people don't use UML. And that kind of goes with what we said here, it's 10% off. So there's a huge percentage of people out there who are not using, essentially what Owen has described as the standard formal notation, the thing that we've got available to us, but people don't use it. So what are we doing? Well, we're doing no UML diagrams, aren't we? You have boxes and lines. And that's fine, but those boxes and lines diagrams need to have meaning. Right? We need to be able to share them. We need to be able to understand them. Otherwise, they're just completely pointless. It's kind of hard to show everything on a single picture. And that's why when you read books, architecture books specifically, you'll often hear them talking about views and viewpoints and perspectives. And if you want an awesome book on this subject, go check out Owen Woods' book. My issue with a lot of the view stuff is that I think the names kind of confuse people. So as a software developer, what's the logical view of my architecture? And how does that compare to the conceptual view? Are these the same, or are they actually different? And if they're different, why? As a software developer, what's the development view? Is that the same as the implementation view? Or is that the physical view? Because the physical view is the code, right? Or is the physical view the infrastructure? But what if I'm on the cloud? Is that deployment? I'm confused now. Has anybody tried to explain views to other people? It's kind of hard. If anyone's gone to look up Philip Crichton's RUP 4+1 model, his initial original definition was very, very clear. If you go and Google 4+1, you'll get 100 different definitions, and they've all mixed the names up. So even 4+1 is a really, really hard thing to explain to people now.
Do the names really matter?
Do the names really matter? That is a really, really good question. What is it we're trying to do here with these names? Essentially, with any diagram, I'm trying to ask this, is this how we coded it? So if we're inspecting an existing architecture through a set of diagrams, I want to answer this question. Because then we can see what we've got. We have a starting point for doing something and moving forward with. So just before we do the next bit, I don't hate UML. Right? People mistake me for being a complete UML hater. I do actually like UML. All the stuff that Owen talked about, I do like. I've done that before. I still do it as well. So I actually find use case diagrams a tiny bit useful when you want to present the overview of a solution, the basic functions and the basic actors. I don't use it for anything else. Activity diagrams, workflow diagrams, yeah, I love that stuff. Great for documenting and detailing process flows, workflows, that kind of thing. Class diagrams, sequence diagrams, state charts, even the deployment stuff I do find useful. But for describing architecture, I'm not so enthralled. UML gives you two things. UML gives you a standard set of notation and diagramming elements, and it gives you a standard set of abstractions. Classes, components, deployment units, activities, and so on and so forth. I think having a common set of abstractions is way, way more useful than a common notation, particularly in a small team environment. Who's ever seen a map? Right, most of us. Do all maps look the same? No. If you buy the Ordnance Survey maps, they all have a standard notation style and color scheme. If you go between different brands and different types of maps, they show the same things, rivers, railways, roads, forests, churches, whatever. But sometimes the iconography and the notation changes. Do maps confuse people? Well, yeah, sometimes. But, you know, can you read and understand maps? Yeah, because they've got little keys at the bottom. And that's how they deal with the, you know, common set of abstractions, but have a different notation. So maybe we could do the same thing. So this is how I break systems down. Who's coming to my session tomorrow? Do this for me for about 5 minutes. So I think of a software system as being made up of a number of containers. And again, for those who went to Owen's talk this morning, basically a container is stuff like a Tomcat server, Oracle database, a messaging server, a database, file system, browser, mobile phone, whatever. Right, somewhere where you can park data or code. Those things for me are made up of components, so I like talking about things in terms of components. What's a component? We've only got 44 minutes left. But for me, a component is a nice small unit of stuff which does one thing and does one thing only. Nice boundary public interface. And because I normally deal with Java and .NET, C#.NET, most of my components are made up of classes. So that's how I implement these things. And sometimes there's a one-to-one mapping between a component and a class. But so what? So this is a basic tree structure. It's a basic set of abstractions that I use to think about and discuss architecture with other people. With this in mind, you can then draw a picture at each level in turn. And I call this my C4 model. So it's context, containers, components, and optionally classes. And I'll show you some examples in a second. But for me, it's the kind of static structure that people have issues with. You know, just drawing and inspecting an existing architecture and communicating the static structure is often pretty tricky. But once you understand the static structure, you can stick sequence of collaboration diagrams on top using the abstractions here. You can do process and workflow across the top of it. You can show deployment infrastructure all around the static structure. Monkeys. Right, we all love monkeys. What? When I moved back to Jersey, Jersey's 9 miles by 5, and it has a population of just under 100,000 people. Current estimates put the IT and tech community at around a couple of thousand people, maybe. But when I moved back to Jersey, I struggled to find the tech community there. Well, I didn't know who was doing what. I didn't know what was being learned, experiences. There were no meetups, that kind of thing. So I created a site, and basically it's a really, really basic content aggregator. And it's called techtribes.je. You can go look at it. And essentially, it shows local news, local blog entries, local tweets, talks, events, jobs, whatever. All of the code's on GitHub. So if you want to go look at the code later, go do Google search, that's the URL, off you go. It's a predominantly Java code base. Spring, Spring MVC, Tomcat, whatever. How would I describe my TechTribes site, my TechTribes architecture? Well, here's a context picture. For anybody who went to Owen's talk, Owen also showed a context diagram. So let's set the scene of what this thing is. This is what I built. It's called techtribes.je. Who's using it? Here are my actors, my roles, my personas. We've got anonymous people, so if you guys go onto the site now, you're an anonymous user, and you can do these sorts of things. Because I'm on the site, I'm one of the people whose content's being aggregated, I can log in with my Twitter ID and do additional stuff, this sort of stuff. And there is a super user on there as well. And one of my key system dependencies, how does TechTribes fit into the rest of the kind of world? Well, I pull data from Twitter. I pull data from blogs through RSS feeds. And if people have registered their GitHub accounts, I use the GitHub API to pull information about their repository. So we list those on the site too. And that's it. You know, that's a basic context diagram for my TechTribes site. Doesn't tell you much, but it sets the scene. Right? And it's a really useful starting point for inspecting and understanding an existing architecture. Let's dive into some detail. Here's a containers diagram. Basically, this box here, this gray box, is the system boundary. So everything inside this is TechTribes. My TechTribes site is made up of an Apache Tomcat web server, which lets people do these things, viewing people, viewing businesses, looking at events, jobs, whatever. The data behind the site, is kept up to date by this thing down here. It's a standalone Java 7 process. It's a content updater. And it's a thing connecting to Twitter, GitHub, blogs, and pulling all that data in. The data is being stored either here in a MySQL database, relational data store, and I'm storing these types of elements, or there's some stuff going into a MongoDB store. Tweets and newsfeed entries, because I can do some nice things with Mongo around, just pulling collections out. And in the middle, there's a shared file system for search indexes. So again, you can do this in UML, but this is my non-UML version. It's kind of a bit prettier. You can put some shading on, because shading is nice. Style over substance. I still got my uses up here. I still got my system dependencies, and I've got some technology choices on here. Protocols, port numbers, and I've annotated some of the lines. What do you think? It's kind of simple, but it kind of explains the logical, high-level technical structure. Web server process and data stores done. Just sets the scene again. And it allows us to go into detail about any of these boxes if we want to. What's the hardest thing in software? Naming stuff, yeah. So let's resist all temptation to have a box with just a single name in it. Do not do that, because it's so open to ambiguity. Let's always have a name and something about responsibilities. Now, here's an interesting thing. If you find it hard to write that statement of responsibilities, maybe you've got it wrong. When you're decomposing, when you're doing design, breaking stuff down by responsibility is a great way to do it. But it's a skill that people have forgotten how to do. Let's open this box up. Let's open up the standalone content updater. What's inside? Well, there's a scheduled content updater. That's a Spring scheduled task. So yeah, you can do this in UML with UML components and stereotypes, but I've done it very simply. What does my content updater do? Well, it refreshes information from external systems. And it's using a bunch of connectors. There's a Twitter connector, a GitHub connector, and a newsfeed connector. And guess what they do? Yeah, it's in the box. They go out to the external systems and pull the data back. So that's the component diagram for my TechTribe's standalone content updater. Looks kind of simple. It is kind of simple. There's a box here which says core components. Core components looks like that. So there's a core library with things like a Twitter component, a newsfeed entry component, a jobs component, an events component. Standard stuff. And that's what the diagram looks like. Again, fairly simple. So that's my boxes and lines style approach to drawing pictures and communicating stuff. And again, on the training course, this is round 2 of the case study, the exercise that we set people. And we get some much, much nicer diagrams. We have a nice context picture to set the scene, one of the high-level technology decisions, and then we zoom into the appropriate container and show components inside it. Cool. So we can take a code base, we can do some archaeology, and now we can communicate it. And that means we can inspect it. We can see what our base starting point is. So the next question becomes this: how do we adapt an existing architecture? How do we change it? Particularly in the face of changing requirements, changing environments, that kind of thing. Who here thinks architectural refactoring is really hard? That's a good chunk of people. Do you think it's really hard, or do you think it's hard because you don't know where you're starting from, and maybe where you want to go to? Maybe. Yeah, if we had a clearer idea of where we were and where we wanted to go, we could map that out. So maybe architectural refactoring is not hard. We just don't know where we're starting from. Yes. Here's another small issue we have in our industry. Does your code reflect the abstractions we put on those previous diagrams? So when we're talking about architecture, it's all kind of fluffy up in the air, isn't it? Oh, we'll have a service that does X, and a component does Y, we'll wire all these things together. Does that component structure map to your code? Oh, some people are shaking heads. Oh, this is not good. So what you're telling me is when you draw pictures of your architecture, you're creating a fantasy, an alternate reality, what you really want it to look like, but instead you've got a big ball of mud. You know, if you look at most Java systems, they're basically layered, aren't they? You know, we'll have a UI layer and a service layer and a data access layer. And because they're in different packages, everything has to be public. So when we talk about a service or a component in a layered architecture, we have to draw a dotted line around a bunch of layers. And then say, well, there's this weird mapping between that nice picture on the wall and this kind of messy code. Well, now it just got hard to explain. You know, now we're adding an extra level of indirection into our explanations. And this is it's going to slow us down. It's making it hard to inspect and adapt to the architecture. Abstraction. Abstraction is basically about reducing detail. It's about simplifying stuff. It's not about creating a fantasy, an alternate reality. But that's what most architecture diagrams actually are. I could talk about this for a long time, but if you're more interested in this type of topic, there's an article I wrote called Mapping Software Architecture to Code. And it talks about exactly this kind of issue. But we're smart people. And smart people in industry have tried to solve this before. So there's a guy called George Fairbanks. Awesome guy, really super smart. He's kind of like part research, part academic, but definitely rooted in industry. And he's got an awesome book called Just Enough Software Architecture. And in this book, he talks about an architecturally evident coding style. And basically, he says this, you know, when you're writing your code, let's put hints into the readers about what the architecture is. So when we draw our nice diagrams with components and services and modules and subsystems, let's label, let's annotate the code to give people hints that that's what we mean. So he talks about, for example, subclassing. You know, you're writing a component, let's have an abstract component superclass. Let's say everything in this one package is a component. We'll have a package or namespace per component, and so on and so forth. He has a bunch of different ways we can do this in Java, C#, whatever. Cool. So we can have our diagrams, and we can embed hints in the code to tell people that, actually, you have to squint a bit because this thing's a component, and that's what it means on the diagram. OK. That works. Yeah? Kind of works. Those diagramming tools I asked you about earlier, Structure 101, and Depend, Lattice, do they see those hints? No. So most diagramming tools, when you point them at a code base, particularly a large code base, they just see classes. They also see packages and namespaces, but they basically see classes. They don't see components. They don't see services. They don't see these abstractions that we have on our architecture pictures. So you could argue that these tools aren't a very good way of inspecting existing architectures. And therefore, if we don't really understand our starting point, it's hard to also adapt them too. If anyone's interested and feels like a challenge, go have a look at the source code for Tech Tribes. Go have a look at the diagrams and see if you can see the mapping. I absolutely guarantee you it's a complete one-to-one mapping. How cool am I? So what's the obvious question here? Did it start out like that? No. Right? Because when I built my Tech Tribe site, I did the classic Java thing of doing things in layers. And then when I drew these pictures for a training course, I was like, you know what? These diagrams are completely pointless. They do not represent the code base. So I went back and restructured the code base. And now I've got a really nice, clean one-to-one mapping between what you see in the diagrams and what's in the code. So there's basically one package per component. So, sketching. I think every developer should learn how to sketch. Why? Because it's a great way to inspect and communicate an existing architecture. Sketching also assists with having much, much better conversations. Why? Because we can crowd around a whiteboard or a flip chart, and we can point to stuff. We can talk about component X and component Y, and we know exactly the abstractions we're referring to. None of this fluffy drawing dotted boxes around random packages, actual one-to-one nice mappings. This is kind of a weird one. So extreme programming talks about collective code ownership. And that's kind of cool. So basically what that says is, as a team, anybody should have the courage and confidence to change any single line of code, anywhere in the system. No silos. Who does this out of interest? Who can genuinely say they do collective code ownership? Wow, like 5 or 6 people. Is that 10% maybe? It's kind of hard to do because most teams naturally form silos around things. They're always experts in certain areas. So I think if you can sketch, if you can see the whole architecture, it enables this to happen much, much more easily. Unfortunately, I've seen teams who are doing collective code ownership, and basically what they're doing is they're relying on tests as a feedback mechanism. So if they break something, they know it's broken. But sometimes they don't know how their code changes fit into the bigger picture. I'll give you an example. I worked with a team to diagram an existing system, a system they were working on that day. We're talking about the containers picture. Is it one web server or two? So they had a desktop web interface and a mobile client. And they were saying, should we have one Tomcat container or two? So what's the obvious question here? How did you code it? Are you deploying a single web application, a single WAR file in this case, to Tomcat, or is it two? One for the desktop web app, one for the mobile web app. Answer was, we don't know. Yeah. Scary, huh? So again, having some sketches on the wall allows people to see that bigger picture, allows them to see where the changes are happening. And for me, sketches are maps. You go onto Google Maps, you look up Jersey. Sometimes you want this nice kind of zoomed in view. And other times you want to go, well, I don't know where Jersey is, so I'll zoom out a bit. Diagrams can do the same kind of thing. We can zoom in or zoom out depending on who we are. Different audiences find different diagrams useful. Owen Wood said exactly the same thing this morning. Non-techies love the big pictures. Techies love the techie pictures. Operational type staff, support staff, there's a nice level of abstraction in the middle there. And for me, pictures are the simplest form of documentation. So this whole agile thing about don't document stuff ever, right? We can use pictures as a way to counteract this. And why is this important? It's important because the code doesn't tell you everything. The code's the most specific version of the truth, but it can't tell you everything. It can't tell you why we came up with that architecture. It can't tell you what the constraints are. It can't tell you which requirements are driving those design solutions, exactly the stuff that Tom was talking about this morning. It can't tell you how you deploy the system, how you support it, configure it, operate it. There's a bunch of stuff you can't get from the code. I've just said that those diagramming tools can't even generate you nice big architecture pictures because they see classes and packages, not components. So there's more stuff we need here. But of course, nobody writes documentation. Agile manifesto, don't write documentation, blah, blah, blah. Yeah, that's not what it says. We all know this. There's no point laboring this point. But people still don't write documentation. They're kind of scared of it. I don't know why. It makes them sad. But many teams have tribal knowledge. Many teams do work in silos, and there are experts in certain areas of the system. You want to know about component X? We go talk to you. Component Y? Oh, you're the expert in that. When these people leave, knowledge walks out the window. Or, and we're in London. London's a properly dangerous place. There are buses. And buses kill. When I was in Oslo earlier this week, they have big, really big, heavy trams. And do you know what? Those trams drive on the wrong side of the road. It's just outrageous. Right? When you're a Brit going to Oslo, it's like, oh, looking the wrong way again. Every other European city does this. It's a conspiracy. So what happens if we have a team of 5 people and some get run over by buses? Well, look, bye-bye. That's a London bus. This one goes on sabbatical. And we fire this guy because he sucks. But he's got really crucial knowledge stuck in his head. And then you have a smaller team asking, well, how does X work? What's an X? Where's an X? I didn't know we had an X. Exaggerated, I grant you. But, teams are downsizing. Teams are losing people. For those who went to Rob Smallshire's talk yesterday, the percentage of code left at the end of a project based upon attrition and churn, that was staggering. especially over a long project. What was your stats over a 20-year project?
Over 20 years, 20% of the code at the end is written by people you still work with.
So after 20 years, there's only 20% of the code left written by people on the team right here, right now. That's a lot of buses. What was it, 114 people you went through?
14 people on a 20-person team.
Wow.
Or through a 20-person team.
That's a lot of knowledge. Now imagine adapting that architecture. You've lost a lot of the rationale about those decisions. So we could go write some documentation. Boo. There are lots and lots of templates out there for doing this. I actually like the content that's in most software architecture documents. I just don't like the approach that they necessarily provide people. So I just think of them as guidebooks. You know, nice, lightweight, thin guidebooks like things you take on holiday. Guidebooks have maps. What's the purpose of a map? It's to help me navigate, essentially. You know, imagine I'm new to London. I've arrived at this hotel. I want to go exploring. I want to go see Big Ben. If I don't have a map, what am I going to do? I'm going to walk out the front door. I'm going to check for buses. I'm probably going to jump on the tube. And hopefully that'll take me round about Westminster-ish, maybe after a change or so. And then I might get out and just have a wander around. And you know, Big Ben's fairly tall, so I can just see it. The police can't go past. That's the joy of London, right? Or you could just leave the hotel and walk and explore. And you'll get there eventually. You might have to ask some people. It's going to take a long, long time. But maps accelerate that learning process. Guidebooks have points of interest, things that we want to see. Most software systems are actually pretty boring, right? You know, if you think about any bog standard web application, let's say there are 200 web pages. It's actually 200 instances of the same thing, but people tend to document the 200 instances. No, the point of interest is the one pattern we're using. That's the thing we want to be interested in. That's the thing we want more information about. So let's detail that and forget the rest. History and culture, how do we get here? What's gone before us? And all the practical stuff around building, supporting, maintaining, operating. So basically what I'm saying is on top of every code base, there needs to be some supplementary documentation. And again, this isn't rocket science and it hopefully shouldn't come as a surprise to many people. But let's make this thing lean and lightweight. And let's make it describe the stuff you can't get from the code. So Owen Wood showed a whole bunch of UML class diagrams today. 10 years ago, I honestly saw people doing that for every single use case. So you build up this whole entire model of the entire system. Use case by use case by use case. It's completely wasted. Who's going to read that low-level information? Us, developers. We know where to get that information. It's in the code. What's not in the code is why we did it that way. So that's what we want to be documenting. Let's reduce any waste in documentation, and let's do stuff only if it adds value. And basically, I use my documentation as a way to describe intent. I promise I will not talk about documentation anymore. So what's the essence of software architecture? How do we blend architecture and agility? How do we do this on agile projects? Where we don't want massive amounts of ceremony, where we don't want massive amounts of paperwork. This basically comes back to just enough. And for me, just enough is basically about understanding the significant structural elements. The things that are costly to change, the overall structure of the thing that we're building. That's what I want to get to know fairly early. And I want to create a shared vision for the team. And I want to create the right structure depending on the requirements and the constraints. So this, for me, is a big part of just enough upfront design, just enough upfront thinking. How do we actually do this? Those diagrams I showed you, that's a really nice kind of template. It's a really nice set of lightweight practices. If you have a blank sheet of paper and some requirements, and you've got a completely green field, go and create those types of diagrams and stop at the component level, because that gives you a really nice kind of breakdown. Make sure you're designing your system based upon the requirements and the constraints, so your requirements are driving your architecture, obviously. Estimation. Who here has to estimate what they build before they build it? Yeah, that's a good chunk of people. If you go to a lot of the Agile conferences, they say, well, we need no estimates. We're not going to estimate. We're just going to build. Everything's going to be one day, and we'll just churn them out, and we'll track velocity and all that stuff. That's fine for certain types of teams. For a lot of people, it's not acceptable. So how do you estimate how much a software system is going to cost? Again, this comes back to something that Tom said earlier. Quantity surveying. How many doors, walls, windows do we need? Count them all up and sum the total. It's as easy as that. So once we go down to understand the significant structural elements in terms of services or components, we can just estimate those things and add them up. It might not be completely accurate, but it's going to give us a ballpark. It's better than going 5 million. So again, we can use some techniques here to help us. Just enough is also about risk. Basically, if you go look at things like the rational unified process, something that's not used much anymore, it's not seen as mainstream, it basically says identify and mitigate your highest priority risks. Why? 2 reasons, really. Reason number 1, if you screw up and you design the wrong thing, or you don't take Tom's advice and look at requirements, you're going to get fired. People like getting fired? No. So that's reason number 1. Reason number 2, if you screw up, your project might get cancelled. And what happens if your project gets cancelled? You get fired. All paths lead to you getting fired if you screw up. So there's an element of self-preservation here. If I'm the architect on the project, I want to be making the right decisions. And I want to make sure that I sort my risks out. So these are basically things that can and probably will go wrong. And Agile projects do have risks. Maybe you're attacking the problem in a different way, you're delivering the system in a different way, but the risks are still there. How? Right, it's all very well us talking about this stuff. How do we actually get lightweight? Tom's in the room, so I don't want to say engineering practices because I'll get shot. But basically, if we have nothing now, how can we improve to do something better than nothing? And maybe use that as a stepping stone to getting to what Tom's talking about, which I think is exactly where the industry needs to go. God, this is a hard question. I've only got 17 minutes left as well. I need to give you an answer. How do we do this? How do we actually get architecture into teams? How do I do this? I work with teams all around Europe. How do I get them adopting architecture practices? Number 1, you need to make sure that all the developers get architecture. And herein lies another issue. If anyone's tried to read any of the kind of classic architecture books, they're brilliant, don't get me wrong. They're really hard to understand. When I was working in London in consulting environments, when I read those books for the first time, when I was moving into the architecture role for the first time, didn't really understand how those books kind of took me into doing the role I should be doing. How does the stuff in the book apply to my day-to-day job? What do I actually need to do as an architect? I found that missing from the books. There's like a huge jump there. So just educate people. Sit down, talk to them about what architecture is. You can do it in half an hour, workshop, internal meeting, you're done. The whole reason I started doing this and talking around Europe and writing books is because architecture needs to be much, much, much more accessible. If we've got any hope of getting to where Tom wants us to go to, we need to get all developers on the same page about architecture. And we need to make sure that people in architecture roles are doing an architecture role. A proper architecture role with proper discipline. And then we can evolve further and further and further. We need to make sure that management understand architecture too. So what I normally do around Europe is I train teams, I train developers. But occasionally I get brought back to train the management team as well, which is kind of cool. And basically it's the developers have said, this is all awesome, and now we get this. We want to make sure our management understand what architecture is, so then we're all on the same page and they give us time to do this disciplined architecture stuff, which I think is just awesome. This also counteracts a problem, and I've only seen this occasionally, but it's a really disruptive problem. Management have jumped on the agile bandwagon, and they basically said to the team, and this is a true story, you're not allowed to do architecture anymore because we've gone agile. No more thinking up front, we're doing agile. Because they've not got and understood what agile is all about. So again, they've kind of had the rug pulled out from underneath them. So again, try and counteract that as well. If you're running agile retrospectives, if you're inspecting and adapting a process, talk about architecture. Example, is there enough architecture discipline happening? Do you think people are going different ways? You're building an inconsistent big ball of mud. If so, how can you stop that? Do you think that too much architecture is being done? That we're spending too much time modeling, documenting, diagramming, inspecting architectures? Now, how can we scale that back down? Is there somebody actually doing this role? Is it one person? Are they overloaded? Can we share the role? Can we make it much more collaborative? Again, talk about these things in the retrospectives. You know, put architecture back on the table. Sometimes talking is not enough, and you have to show people. You have to demonstrate what just enough architecture is about. And this is exactly why I do architecture carters. So what I mean is basically, I give them a problem. So I use a really basic risk system for my training course. If anybody wants a copy of this set of requirements, they're in the back of the book. If you want a PDF, email me. I'll quite happily send it to you. You know, and run this kind of thing with your team. You can use your own requirements, but keep it simple. You know, you want something that you can design in about 45 minutes to an hour. And essentially it goes like this. Get people in groups, give them some requirements, and say, go design something. And communicate it through diagrams. Come back, look at diagrams. This is exactly what we'll do tomorrow. Again, do this if you're coming along. Look at diagrams, give some feedback, and then repeat the whole thing again. At the end of it, what we normally find is we get a really nice set of pictures. We get a really nice understanding of the significant structural elements. We force people to think about responsibilities. We force them to think about decomposition. We force them to think about, you know, is the architecture actually going to satisfy the requirements, functional and non-functional? You said it with Tom in the room. The quality attributes. And is it going to fit in with the constraints of the environment? And again, that set of diagrams, my C-form model, the context, containers, components, that's a really nice place to stop. You can design an entire system in a matter of days and have a really, really good understanding of that system and create a vision that the team can work from. So again, you know, basically the whole point of this carter is to do this. Get people familiar with doing pair architecting and collaborative design. It's to teach them architecture sketching and actually communicating, because we need that if we're going to create and inspect existing architectures. And it's a great example of just enough upfront design. Don't set them a carter and say you've got a month to do it. That's not what we're after here. You know, time box it to 90 minutes. Force them to think hard. I said risks are important as well. The big problem with risks is that if you have a list of risks, those risks are normally managed or owned by a non-technical project manager. For me, the architect has to look after the risks. You know, that's fully in the role of the architect. Whether that's one or many people, doesn't really matter. How do you get a list of risks? You could email people. Dear all developers, please give me a list of all the technical risks you see on this project. Lots of love, architect. Right? Response is going to be, I haven't got time. It's not something we're familiar with as developers. So I teach people a technique called risk storming. And basically, you know, step one is draw some pictures of your architecture, visualize it, so you can inspect it. Step two, get everybody you can alongside the diagrams. Developers, BAs, testers, PMs, doesn't matter. And get people to identify the risks that they perceive with that solution. So this is something you can do either at the start of projects or, you know, at the start of every sprint, for example. You get people to write little sticky notes, ideally color-coded according to priority. You time box that exercise for like 5, 10, 15 minutes, and then you get everybody to stick their sticky notes on the pictures. So it's a kind of classic game storming, innovation game style technique. So essentially, we're eliciting feedback from everybody, not just that one project manager, not just that one architect, the whole development team, because risks are essentially subjective. So this is a great collaborative way to get a list of risks, and then you can do stuff about them. Don't ignore them whatever you do. Don't just leave them on your pictures, actually do stuff about them. So changing your architecture, hiring people, doing proof of concepts, for example. So we've got to like 82 minutes, and then I've said, so what? I was talking to some guys who have links with some of the academic research community, and I was trying to get a paper peer-reviewed for entry into one of the journals, and basically they said no. And they said, you're not adding anything to the whole architecture agile debate. It's been done before. It's all old news. Thanks. So what do we do? You know, there's a whole community out there who think all of this is old hat. If it's old hat, why are there so many agile architecture sessions in this conference? Why are we all here? Why are you all here? Why am I flying around Europe week in, week out, teaching people how to do, you know, lightweight software architecture on agile projects? It's because the 99.999% of the industry outside of academia does not get this, and they struggle with it. And that's kind of weird. What do we do? You know, we're changing the world one team at a time. It's a very noble goal, but it's going to take me forever. So I need you to help me. A lot of teams they'll freely admit to me that they don't do architecture. You know, that's kind of why they get me in. That's why people like you guys come to conferences like this. And many teams don't understand or practice architecture. So, you know, whether that's what Tom was talking about this morning, or whether that's what I'm talking about now, you know, just doing some thinking, some architecture. Many teams don't even do this. And if you want to be agile, if you want to create agile environments and agile architectures that change and adapt to your requirements, you've got to get better at doing this. You've got to get more disciplined. So as a community, and the great thing about conferences is that it's a self-selecting audience. So we're all up here compared to the rest of the industry. So basically, it's up to us. We have a duty to educate other people. So I would urge you to take some of the ideas here that you've seen. Now, don't blindly copy them because that's why people fail. But take some of the ideas, the thoughts, back to your teams. Educate other people. And let's hopefully get to a point where we can start looking at what Tom was talking about and bringing those engineering disciplines back into what we're doing. This is about scaling teams. Thank you very much. Much, much, much more accessible. So when I worked here in London, one of the things that we needed to do as a consulting company was to scale the number of teams we had. And in order to scale the number of teams, we needed to scale the number of technical leaders, in other words, the number of architects. So essentially, you know, internally, in-house, we did some architecture training. And that is, in essence, what all of this stuff has become. I started writing a book about 18 months ago. It's an ebook on leanpub.com. As a thank you from me to you, I'll flash you up a code at the end, which you can use for a discount. What am I going to talk about? I'm going to brush across a lot of the topics we've seen already in the conference. So Rob Smallshire talked about architecture in a kind of agile world. We'll touch upon some of that. Tom Gilb in his keynote this morning talked about architecture as an engineering discipline. I think he's completely right, by the way. I think we should be striving to make software much more of an engineering discipline. I don't think we're ready yet. I think he's potentially 20 years too far in the future. You know, we've got some work to do right here, right now. But the principles are absolutely sound. And I'm going to talk about drawing pictures. Charming. I'm going to talk about drawing pictures. So if anyone went to Owen Wood's talk this morning about UML, I'm going to talk less about UML and more about communication through pictures, through sketches. Oh, God, I've got to start with this, haven't I? You know, what is architecture? Tom said there were like 200 different definitions out there on the SEI website. Mine's really very simple. Architecture is about structure, so the boxes and lines the things, the components, the modules, the subsystems, and how they link. How you decompose something. But it's also about vision. Given this blank sheet of paper and some requirements, how do we create that architecture, and why are we making these decisions? So one of the things that Tom said is essentially requirements drive architecture. Without requirements, there is no architecture, there's no purpose here. Excellent. Hello, everybody. And welcome back after lunch. How are you feeling? Sleepy? Uh-oh. At least it's cold in here. I'm Simon, and we're going to be talking about software architecture, obviously, and the balance with agility. Some background on me. I live here. Everyone's going, oh, what's that? It's about a 3-pixel wide island called Jersey. It's near France. Why? Basically, I was born there, went to school there, ended up going to the UK, went to university, worked in London for about 12 years, mostly for consulting companies, predominantly doing Java stuff. I have some small boys, 9 and 6, and we moved back to Jersey about 5 years ago. Lovely place for children to grow up. Not much Java. So I kind of faced a choice. Do I give up, teach people how to surf? But at the time I couldn't surf. I can now, debatable. Or do I switch technologies? So I jumped onto the .NET stack. It's complicated, right? The next question is usually, is Jersey part of the UK? Do you use the same money? Do you have your own laws? It's kind of complicated. I'll just refer you to this awesome YouTube video. What do I do now? I guess for the past couple of years, I've been helping software teams understand software architecture. And that kind of sounds crazy, but in my experience, a lot of software teams don't get architecture. So I've been helping them do this, and I've been helping them understand how to do architecture in agile environments. And again, these things seem to conflict. I've traveled all around Europe over the past 2 years. I've spoken in China and I've spoken in the US, and I see the same patterns repeated over and over again. I do code as well. So granted, I've not coded as much as I'd like this year, but I'm a software developer by trade. That's what I do. Why do I want to talk about software architecture? For me, it needs to be made. What happens when you give a big set of documentation to a separate development team and say, go build this, I've thought of everything for you? Does it get read? No, sometimes not. Sometimes you might get halfway through and then your head hits the table as you fall asleep. But generally, we don't like getting that sort of guidance. What's the point of this? The point of this is that that document is there to create a shared understanding, a shared vision that the team can work from. But the actual vision that's being created there is this. To use an internet acronym, too long, didn't read. Right, which kind of brings us back to chaos, because we're not working in a consistent way. Do we do this anymore? Nah. Why? Because if you go to the Agile Manifesto webpage, what's item number 1? Item number 1 says, don't write anything down. It doesn't really, but that's the kind of lazy modern interpretation of the Agile Manifesto to some degree. So what do we do now? How do we create a shared vision amongst a team of people? Who here uses UML? Show of hands. Is that 20% maybe? Maybe slightly more. What's everybody else doing? Boxes and lines. Yeah, lots of people just do boxes and lines. So there are some teams who just jump into doing coding. And there are some teams who actually go, hang on a second, let's think about this. Let's go over to our whiteboards and let's sketch some ideas out. And this is the thing we're going to build. Sometimes that's not very effective. And so we get a different type of vision created. You'll have to look this one up yourselves, but sometimes we get this. And again, if there's no consistent vision here, no consistent understanding, we're basically back to chaos, which means stuff's not going to work. So for me, the whole essence of software architecture is to reintroduce structure and vision back into software teams in the way that they work. So we can build stuff that looks nice. We can build stuff that's well-defined. We can build stuff that actually works. And with IntelliJ, Eclipse, you can refactor a lot of stuff very, very quickly, but you can't refactor some of those significant decisions. What's the whole point of architecture? Right? For me, it's to avoid chaos. a number of teams that I see are basically in chaos. Okay, if you ask them these two basic questions, do you know what you're building? If they can't answer you, if they can't say, here's a list of features, or give you a quick 5-minute elevator pitch on what the system is supposed to be delivering, then yeah, maybe there's something wrong here. I've worked with teams, and they've often not known how they're building it. So one of the systems that I kind of took over a while back, it was a .NET system, end-tier architecture. If you asked a developer on the team how they would build a web page through to the back-end services, you'd get different answers depending on who you spoke to. So people had different views of the layering strategies, for example. Again, that seems to strike, that's chaos. And we need to stop all this, because if we don't think about architecture, if we don't think about significant decisions, we get a mess, essentially. Big balls of mud style of architectures with no defined structure. Who's working on these? You're all liars. You're all working on these things, right? Or you get systems that don't work. They are too slow, they don't scale properly, they have security issues, they're hard to deploy, they fall over, that kind of thing. And again, architecture allows us to think about some of these characteristics. How have we as an industry traditionally tried to prevent chaos? Well, what you do is you go find an architect. You hire an architect. You point them at a problem, and they come up with a solution. And sometimes they document that solution. Nice, thick, sad. How does that make you guys feel? Yeah. Yeah. Sometimes when you pass out on the table. So yeah, definitely agree with him there. What's software architecture more specifically? There are a couple of terms kind of banded around. Application architecture is one that most developers are familiar with. Take a code base. It's about structure, layers, components, APIs, programming languages. It's quite code-focused. Systems architecture is kind of a bit more high-level. Again, there's a very traditional definition of systems architecture, and it's around software systems, components, modules, and hardware. This is way, way different, enterprise architecture, not what we're talking about at all. So we could talk for the next 84 minutes about software architecture, but let's not do that. For me, this is software architecture. It's everything from lines of code, organization of code, structure of code, up to making sure a software system works end to end. Integration points, the whole lot. It includes infrastructure and hardware. And it has to, right? Again, Tom talked about constraints being one of the big driving factors behind an architecture. Target deployment environments, hardware, infrastructure. Again, a key constraint here. Now, I'm not saying that we should all go out and be able to create networks and provision infrastructure, although that would be cool, the whole DevOps movement, but we should understand infrastructure. We often use the word design a lot. When I'm designing something from scratch, when I'm doing architecture, what's the difference? Grady Booch had this nailed a long time ago, in my view. So Grady Booch basically says, architecture is about the significant stuff, significant decisions, things that are expensive or costly to change. Choice of language, choice of technology, choice of platform, choice of the overall architecture, client-server, rich app on your mobile rather than a phone gap type app, for example. These are the major significant decisions that you kind of need to get right because they're expensive to alter later. We've got some great refactoring tools now. ReSharper,